Yeah, and thanks also to Tim and everyone else who made it happen. Such a great conference today. Yeah, in general, alternate data transport layers have been an interest of mine for many years now because whether it's interfacing with Ethereum or other networks, most people don't consider the actual lower level than Ethereum of the stack, which first is the internet, and then even lower than that. But whether you're interfacing with the internet or just Ethereum, the RPCs can censor you, ISPs can censor you, and looking at these layers of the stack is really interesting, especially if you care about censorship resistance. So, looking at below the level of Ethereum as L0, you can go to L-1 internet. The internet in general is very decentralized from a physical infrastructure perspective, super resilient to naturally caused outages and so on. But ISPs have a knack for being government regulated and can censor anybody at will like that. So it's mostly a problem of deliberate censorship rather than natural outages. So from one perspective, it is sufficiently decentralized, but not so much on where it actually counts and the access to it. So if you look at the energy of the universe, that's sufficiently decentralized. You don't have to look about that. Electricity infrastructure is pretty good as well. You can deploy that yourself, and you don't have to worry about that. So the internet is really where it starts to matter, and I encourage everyone to look at the whatever we're building from the entire, opening up to that entire perspective. So yeah, internet is not decentralized enough. The censorship risk is just conditionally high just because it depends on your location, the government that's imposing the regulations on you, and so on. And it's also, like somebody said earlier as well, it's an economic wall as well. In many developing countries, there's these kind of packages where you can buy only access to just WhatsApp, for example, for a fixed fee per month, and then that is your entire internet reality. So you can't even get access to the whole internet if you just don't have enough money for it in general. So, thinking about how we can solve these problems and give people anywhere in the world access, especially in places where the ISPs are super prohibitively expensive, or in general just restricting certain kinds of transactions and information flow, is a complicated problem. So yeah, one potential solution to that is what we'll talk about. And but first, why? I think this is pretty obvious to everybody who's here. We want to make sure everybody has equal access to communications and can evolve as a part of a collective humanity together. And it's just going to happen way better if everybody has this freedom of communication. So, basically, what I've been doing some research on over the past few years is radio. And you can use these radio waves to, people communicate all the time just as hobby as well as military, and there's so many use cases for really long-range radio, but it's very low bandwidth. So what you can expect out of systems is very 10 kilobits per second or something like that, and yeah, but that's plenty if you're just sending transaction data. So if you want to make sure that you have a little piece of information, like I want to send a friend of mine some Bitcoins or Ethereum or whatever your favorite cryptocurrency is, you can just do that over radio waves. So the basic steps listed here, which we'll go over. It only requires really one non-internet connected actor to transmit a message out and it to be received by one actor who is connected to the internet. And then can pass that message along to whatever memory pool there is. So yeah, first there's tons of software out there that you can use to encode data into audio, which then is super compatible with all the existing infrastructure that we have to broadcast radio signals. Most radio is in the form of audio, but this converts it into a digital format. So yeah, there's tons of encoding algorithms, tons of open source software. This is a really good one called FLDigi that has built-in error correction and yeah, tolerates a significant amount of loss depending on the encoding algorithm that you use. And then yeah, you can just broadcast that. There's there's a lot of people that are known to be very Bitcoiner prepper types that really are into building out self-sufficient infrastructure and have camps in the woods with broadcasting stations and stuff like this. And there's one example from 2019 where people transmitted a Bitcoin transaction across all of the United States completely just peer-to-peer directly wirelessly without going through any intermediaries that could possibly censor it. It's pretty incredible that really long range can be achieved with very low power. So with devices that you can build relatively easily, you can transmit across the entire world. You can bounce signals off of the moon and back. There's a repeater on the International Space Station. There's tons of ways to get messages out, even if you're living in a very, very difficult situation. So then, all you have to do is use some relatively inexpensive hardware. Like this radio costs less than $50. To receive the signal, you can attach a hefty antenna to that, which you can build out of basic materials that you can find at any hardware store. And you just connect that back down to a similar software package to decode the encoded audio stream to get the transaction data out of that. Then all you have to do is to decode that, and the visual representations of the audio basically is just like little blips on different parts of the frequency bandwidth that you're actually using, and it's really, really fun to look at these signals, to start sending these back and forth to friends and just see how it works. But then all you have to do after you decode the transaction data is just like any other transaction that you would normally interact with. You just send it to the mempool, and it gets in the queue with all the others, just like it originated from somewhere else on the internet. So what you're effectively doing is building a proxy for people who don't have access to whatever part of the internet they actually need, or the internet in general, to submit these transactions. So the biggest issues around this are coordinating which frequency and which encoding algorithm do we want to use. So creating a standard for that could be something that's really interesting. This is actually a really, really huge issue, but figuring out some kind of standard for that, as well as potentially creating a protocol which automatically saves the data and then runs it through all potential ways of decoding it, and then automatically processes this data accordingly, could be interesting. As well as in a lot of jurisdictions, you're limited to a very low wattage of how much you can actually transmit, and this can limit the range. But with, for example, if you're using like a low frequency transmitter with about 3 watts of power, which is generally legal in most places, you can transmit thousands of kilometers. So this is a really interesting technology for that. So in general, the way forward is going to be a big mix, but I think as long as people keep thinking about this layer of the stack and working in that direction, it's looking bright. So in addition to just being a dumb transmitter of data and not being sure whether anybody's out there receiving it, a thing that requires a bit more infrastructure, because you have to also be able to receive a signal again, and the receiver has to be able to send. But that's implementation of acknowledgement receipts, so that at least you know that your transmission has been received and transmitted to the blockchain. That would be an obvious thing. And then once you have bidirectional communication set up, you can actually implement IP networking, and then you can have multi-hop networks, where instead of just being point-to-point, you're communicating with different users through a whole thing. So you can actually run IP network on radios. It's super low bandwidth, super high latency, but what matters is like getting the data out in a otherwise like a censored situation, it can be super useful. Otherwise, standards, guides. I mean, a lot of the hardware that you need for this, you can find, at pawn shops and hardware stores. So just making guides and distributing those to folks who might find them useful is a project that, some people like the M17 project are kind of working on, but it's definitely not, like, they haven't made it easy yet. And there will also be other alternatives other than this. Like, it's a lot more expensive, but launching our own, DAO-owned net constellation of satellites as an alternative to Starlink, things like that. So in general, if any of you folks are interested in working on this kind of thing, there's a few discussion groups that are starting as a result of this day. Some of them are focused more on the like libp2p stack. If you're interested in working on the internet level or below, yeah, you can hop in that group. But yeah, happy to take any questions. Thanks.